we are going to continue our study of and space. And so, just to flip back in the science folder, you should have taped down where we kept track of the hours of daylight in Alaska. And we used that extreme example to show that in different seasons, where Earth is in space is experienced by us on Earth in measurable ways, like by how much daylight we have. We then shifted to talk about how Earth's place in space also relates to the way constellations appear to us. You took some notes last week on that. You also put together a planisphere, and now I am wanting you to attach that planisphere here in your science folder. So I just taped the side and the bottom. I also made a little ball of tape to get this left hand because it sticks out a little bit, but I wanted it not to stick out too much. Today's main focus then is to begin talking about the stars themselves and what they look like on Earth. Not exactly the shapes that they are in, but the brightness of those stars. So we're going to begin by defining two words and watching a short video, and that will be today's science. The words that you need are apparent magnitude and absolute magnitude. The magnitude of anything talks about its size. Apparent means this is the way it looks. Absolute means if we measure it, if we don't really pay as much attention to how the thing looks as to how it measures, keeping everything equal, this is how big it is. The vocabulary that you need down on the other side of the card look like this. Apparent magnitude is the brightness of a star as it appears from Earth. And yes, you'll notice I'm emphasizing specific words. Appears, apparent. It looks this way. A few other pieces of information here. The farther away a star is, though, the less bright it appears. The closer you get to the star, the brighter it appears, and if a particular star is closer to Earth, it looks brighter than stars that are farther away. You kind of see this if you're riding along with your parents at night and the headlights of other cars. Farther away, you can see that there's light, but they're not really bright. The closer those lights get to you, the brighter they are. When you take driver's training, oh dear, you will be old enough to do that in just a few years. When you take driver's training, they will probably tell you something to the effect of if you are driving at night, you don't want to look into the lights of an oncoming car. It's best to look at the reflective painted strips on the highway to keep yourself aware of where you are on the road. If you look at the oncoming car, the closer it gets, the brighter that light is, and you can lose track of where you are in the road and drive towards the light, which is not a good idea because the light is another car. The other definition that you need here is absolute magnitude. My bad. Absolute magnitude is the actual brightness of a star with distance canceled out. And so it's when astronomers say, okay, if we could get all of these stars that we're looking at exactly the same distance from Earth, this is how bright they really truly are. When I looked some of these videos up on YouTube, it was interesting to me. There is a lot of physics involved,
and
you can be quiet.
Be
quiet. There's a lot of physics involved, and so you can find a lot of YouTube videos that discuss, in order to find the absolute magnitude of a star, exactly the measurement of how bright a star is. We are just going to watch this video. It's a short one, and it should help you understand a bit better. It's not a physics one. So, should help you understand even more the difference between apparent magnitude and absolute magnitude. We'll start it over since it wanted to start early.
In the sky, we can see stars and other celestial bodies of different brightness. In the 2nd century BC,
so these two objects would have a very great apparent magnitude. These two look much brighter than the others. Absolute magnitude, well, it'll get there in a bit.
Ptolemy introduced a method of classifying stars according to their brightness. The brightest objects were said to be of the 1st magnitude, while the faintest were of the 6th magnitude. Later, however, a more precise classification was required, and Ptolemy's scale was extended. Nowadays, the brightness of celestial bodies is expressed in apparent magnitudes, which can also assume negative values. The lower the apparent magnitude, the brighter the observed object. For example, the apparent magnitude of the full moon is equal to -7 mag. The brightest star in the sky, Sirius, has an apparent magnitude of about -1.4 mag, while the best telescopes enable us to observe objects with apparent magnitude of as much as +23 mag. Since the apparent magnitude depends on the distance of a star from the Earth, and not only on the amount of radiation which is emitted by the star, a quantity known as the absolute magnitude is also used. This is equal to the apparent magnitude if the observed object were placed at a distance of 10 parsecs from the Earth.
So remember I said absolute magnitude tries to cancel out the distance. So it showed if you could take the object that you're looking at and move it 10 parsecs, and that's just an astronomical unit. You don't have to worry about how much it is to us. But if you took it and put it that close to Earth, that would be the way that they cancel out distance.
The absolute magnitude defines the luminosity of a star. In the sky...
No, not again. So, do be sure that you have these note cards filled out. We did not put examples on here, although if you wanted to go back and watch the video and put an example of each, you can. The examples aren't as important with this part of our study as the fact that stars can look a lot brighter than other stars, but because of their distance, they're not truly that bright. So the difference between what we see on Earth and what truly is, as far as the brightness of stars, are two different measurements. Hope that was clear.